Welcome to my channel Everything Nepal. Guys, from today I am starting a mathematics series in which problems related to ISC first year, second year, ISC AG first year, second year, and not only this, the problems related to B.Ed science second year will be discussed. This is the first part of the mathematics series, and within this first part of the mathematics series, I will be discussing about the measures of central tendency. I will also tell you the use of the measures of central tendency, and I will be solving the problems related to the measures of central tendency. But before starting the very first video of mathematics series, guys, if you have not subscribed my channel, then please do subscribe and also give like and comment. Students, in this very first part of the mathematics series, I will discuss about the measures of central tendency. And today I will solve the problems related to arithmetic mean from all the series, that is individual series, discrete series and continuous series. So let's start. If you see measures of central tendency, then we can see three words here. First, measures, second, central and tendency. The literal meaning of these three words is measures means the measurement of that quantity which tends to cluster centrally. If you take an example, let us consider an example 1, 2, 3, 4 and 5. Then if you find out the arithmetic mean, then we have to sum up these 5 observations and is divided by the number of observation, that is 5. So we get here 15 divided by 5, that is 3. So what we see here, 3 is centrally located around which another observations tends to cluster like 1, 2, 4 and 5. So what we see here, 3 is centrally located around which other observations are located. So this means the 3 is the typical value and which represents the whole distribution. Similarly, measures of central tendency are also called as the measures of locations. It is also termed as averages or the means. And among measures of central tendency, there are so many measures, namely they are arithmetic mean, geometric mean, harmonic mean, median, mode and weighted arithmetic mean. But in this today's video, I am only discussing about the arithmetic mean. So if you concretely define arithmetic mean, we can say that arithmetic mean is defined as the ratio of the sum of the number of observations and divided by total number of observations. That is, let x1, x2 xn be the number of observations and n be the total number of observations, then AM denoted by AM arithmetic mean x bar is given as x1 plus x2 plus dot 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 plus xn and is divided by total number of observation, that is n. And when we sum up these observations, we get x bar is equal to summation xi divided by n, where I runs from 1 to dot dot n. So this is the formula, this becomes formula of the arithmetic mean in case of individual series. For individual series, similarly we can also give the formula for the discrete series and continuous series. Now in case of discrete series, as we already know that discrete is the series in which the observations along with their corresponding frequencies are given. So in case of discrete series, arithmetic mean AM arithmetic mean denoted by x bar is given as summation fd divided by n. What we have to consider here, that in case of individual series we had taken a small n, but here we take capital N, as capital N represents the total number of the frequencies, that is sum of frequencies. Since in case of discrete series the frequencies are also given, so in case of discrete series, instead of putting a small n, we put capital N. Now this is the formula for the discrete series. This formula is called the direct method formula. Direct method. We can also take a formula in shortcut method. The formula becomes shortcut method. Arithmetic mean AM denoted by x bar is given as a plus summation fd upon n, where a is assumed mean and d is the difference of x and assumed mean. Similarly, for continuous series, the formula from the direct method becomes, number first, x bar is given by summation fx by n. This is direct method. Number second, x bar is equal to a plus summation fd by n. This is called shortcut method. And third number formula is x bar is equal to a plus summation f d prime by n into h, where a is assumed mean, d is equal to x minus a upon h, or interval. H is for interval. This formula is known as step deviation method. Now we will solve the problems based on these all formulas. Let's take an example, that is, find the simple am from the following data. That is 8, 4, 12, 16 and 10. So by applying direct method, we can get the simple arithmetic mean as x bar is equal to, as we know, the formula is x bar is equal to summation x divided by a small n. So here what we do is we sum up all these observations, that is 8 plus 4 plus 12 plus 16 plus 10, and is divided by the total number of observations. And here the total number of observation is 1 2 3 4 5. So we divide by 5 and we get here 50 by 5, that is equal to 10. So here the simple arithmetic mean becomes x bar is equal to 10. Similarly, by shortcut method we can get the arithmetic mean. As you know, the formula is, as we know, the formula for the shortcut method is a plus summation d by n. And if you consider the same problem as given above, then we can find the arithmetic mean as, suppose x is 8, 4, 12, 16 and 10, and d, that is d is x minus a assumed mean. So here let us suppose that 12 is the assumed mean. Let's take 12 as a assumed mean. Then the difference of 8 and 12 is minus 4, and the difference of 12 and 4 is minus 8. Similarly 0 and is 4. Similarly this is 2. So summation d becomes, at summation d becomes 8 and 4 are 12. From these observations we get here 6 plus 6. So now applying shortcut method, we get assumed mean is 12 plus summation d becomes 6 by 5, and which is equal to In case of shortcut method, that is x bar is assumed mean plus summation d by n, and if you consider the same problem as above, which is 4, 8, 10, 12 and 16, then x is 4, 8, 10, 12, 16, and d is the difference of observations x and assumed mean. We get, if you consider the middle term as a assumed mean, then the difference of observations and assumed mean becomes -6, -2, 0, 2 and 6. So it total summation d becomes 0. And now applying the above formula, that is shortcut method, we get x bar is a plus summation d by n. That is, here we have taken a as 10 plus summation d is 0 by 5, and that becomes 10. So in the either case, the arithmetic means are 10. So in either case, we have got the arithmetic mean as 10. In this way, we can obtain the arithmetic mean in case of individual series by both of these formulas, that is shortcut method and direct method. Now similarly in case of discrete series, discrete series, we have also two formulas. That is, number first is x bar is equal to summation fx divided by n. This is called direct method. And number second formula is x bar is equal to a plus summation d fd divided by n. This formula is known as shortcut method. And let us take an example in case of discrete series, that is wages in Rs and number of employee as 10, 15, 20, 25 and 30. Similarly, the number of employees are given as 10, 10, 15, 10 and 5. So as we know that this is the case of discrete series, since here is given the number of observations as well as the frequencies. So here from this example we can get the arithmetic mean by applying both these formulas, that is direct method and shortcut method. And now if you consider the number one formula, that is, and now if you consider number first formula, that is direct method, then x is 10, 15, 20, 25 and 30. Similarly, frequencies are 10, 10, 15, 10 and 5, and the product of frequencies and number of observations are given as 100, 150, 300, and 250, 150. And if you sum up these product of the fx and x, then we get summation fx as 0, 5, 5, 10, 15, 5, and carry over 1, 3, 6, 8, and 9, 950. So we have from direct method x bar is equal to summation fx divided by n. Now by putting these values, 950 divided by total number of observations are as 50, so this becomes 19. In this way, from direct method we got the arithmetic mean as 19. Now consider the shortcut method. Considering the same problem, this is the same problem as we have discussed earlier, and from this problem, by applying shortcut method we can obtain the arithmetic mean. So let us consider 20 as assumed mean A, and now we get the difference of observations and assumed mean, that is minus 10, minus 5, 0, 5, and plus 10. So when we multiply frequencies and the differences of x and assumed mean, we get minus 100, minus 50, 0, 50, and 50. And when we sum up these products, we get summation fd is equal to minus 50. And now we know the formula x bar is equal to a plus summation fd divided by n. And now putting all these values, we get n is equal to 20 plus summation fd is equal to minus 50 divided by 50. So here it becomes 20 minus 1, which is equal to again 19. So we saw that in both cases, from direct method as well as from shortcut method, we got x bar equal to 19. So in either case the arithmetic mean becomes 19. Now let us consider continuous series. Now let us consider the continuous series. In case of continuous series 2, we have two formulas. That is, number one formula is x bar is equal to summation fx by n. Second number formula is x bar is equal to a plus summation fd divided by n. This is direct method. Shortcut method. And third one is x bar is equal to a plus summation fd prime by n into I or h. So applying these all formulas, we can get the arithmetic mean at the same value. So let us take an example. Suppose we have the problem as calculate the mean for the flowing data. In case of continuous series, we have altogether three formulas. Number first is arithmetic mean is equal to summation fx by n. This is called direct method. Second formula is x bar is equal to a plus summation fd by n. This formula is shortcut method. And the third one is x bar is equal to a plus summation fd prime by n into I, where a is assumed mean, as we have discussed earlier too. D is equal to x minus a, and d prime is equal to x minus a divided by interval, that is I or h. And now let's take an example to find out the arithmetic mean from all these formulas. So this is the question where numbers are given in the interval or range and frequencies are given as 4, 6, 20, 10, 7 and 3. And now we have to obtain the middle terms, and the middle terms is obtained by adding up lower limit and upper limit, and it is divided by 2. So when we add 0 and 10, we get 10, and divided by 2 is 5. Similarly, we add up these 10 upper limit and lower limit, 10 and 20, this becomes 30, and when divided by 2 it becomes 15. Similarly, we can get 25, 35, 45 and 55. And now D becomes x minus a. Similarly, D prime becomes D prime, as we have told earlier that x minus a by I is the D prime, so it is known. Now fd and fd prime. So the differences of x and assumed mean are, when we take 25 as the assumed mean, then we get, if you make the differences between x and a, we get minus 20 and minus 10, 0, 10, 20 and 30. So d prime becomes, here the interval is 10, that is I is 10, here I is 10. So D prime becomes minus 2, minus 1, 0, 1, 2 and 3. And now when we multiply the frequencies and D, that is the deviation, then we get 20 is multiplied by frequency is 4, so it becomes minus 40. Similarly, minus 60 and it becomes 0. Similarly, it becomes 10 and 14 and 90. And now when we multiplied D prime and F, it becomes minus 8. Similarly, minus 6, 0, 10, 14 and 9. And the sum of fd prime becomes 19, that is summation fd prime is 19. Here we can write summation fd prime is equal to 19. And now let's do calculation. So first formula is direct method, which is x bar is equal to summation f x or fm divided by n. So we have got summation fx is equal to, so by using direct method we have already obtained the arithmetic mean, and also using the second method, that is shortcut method, we have also already obtained the arithmetic mean. Here we consider only step deviation method. That is number third method is x bar is equal to summation a plus summation fd prime divided by n into I, which is a step deviation method. And shortcut method is x bar is equal to summation a plus summation fd by n. Here consider only third formula, that is x bar is equal to a plus summation fd prime by n into I. So a is obviously what we have considered here. Assumed mean is taken as 25, so it becomes 25 plus summation fd prime we have obtained as 19 divided by 50 into 10. So it goes out, and when we uh, divide 19 by 5, we get 3.8, and altogether it becomes 28.8. So by using all of these formulas we get the same value, that is 28.8. Though we have not used all these formulas here to obtain this the same value, but when we solve from these all formulas we get the same values, 28.8. So that's all for today. If you have any comment, if you have not understood anything, please do comment.